My dear viewers, you are most welcome to Algebra Mathematics channel, and specifically to this presentation where we are proceeding with our topic, linear simultaneous equations. And please, if you are on this channel, kindly subscribe, turn on the notification button so that you are notified whenever I upload a new video, like and share. Tonight, we are going to look at how we can solve simultaneous equations using the matrix method. So in the previous videos, we looked at how we formulate simultaneous equations from scenarios. Then we are now on part B, where we are solving simultaneous equations. And among the previous videos or presentations, we talked of how we solve simultaneous equations using the elimination method. We also talked about or learned about solving simultaneous equations using the substitution method. And in this video, we are going to learn how we solve simultaneous equations using the matrix method. So please, if you want to understand better, watch up to the end so that you can benefit a lot from this video. Let us now jump into the video. It is method 3 because I said earlier on we talked about or we learned about solving simultaneous equations using the elimination method and then substitution method. This time around, we are looking at how we can solve simultaneous equations by matrix method. And under matrix method, we have the subdivision of the matrix method of solving simultaneous equations. We have part A, which is now the adjoint matrix method. So in here, we solve the simultaneous equations using the adjoint of the matrix formed. Then in part B, we have the inverse matrix method, whereby we need to first get the inverse of a matrix formed after forming the simultaneous equations. And then there we go ahead and simplify. So we are going to look at each one of the two here under the methods matrix of solving simultaneous equations. So let us have the examples here. We have example 1, which reads, two numbers are such that their sum is 27 and their difference is 13. Express the statements mathematically in order to relate and determine the values of the two numbers. So this is our scenario, and we are going to work it out by having our response here. From the question, they are talking of two numbers. Say that their sum is 27. So we can begin by letting. And why do we let? We want to get these variables here. So we just get some letters which represents the variable they are talking of. And there are two here. There are two variables or unknowns we are supposed to let. So let us let maybe x and y be the smaller and the bigger value, or bigger numbers respectively. So when you say respective, it means that x is a smaller one compared to y. So the next step, we are going to mathematically analyze the statements and represent them mathematically using the x and y as the variables or unknowns. So they are saying that the two numbers are such that their sum is 27. So in other words, it means that we are going to add them. If we add the x to y, they are saying that the answer we must get should be 27. And this is our first equation. Then the other one is talking of their difference is 13. But we say that x is the smaller one. And since 13 is positive, it means that they go to y, which is the bigger one, then take away the smaller one, which is the x. And they're saying this should be equal to the 13. This now becomes our second equation that we have formed. From there, we have to go ahead and solve those two equations formed. Remember, we have the two equations, which are the x plus y, giving us the 27 as our equation 1. Then the y minus x being equal to the 13, which we have named equation 2. So in here, we have already the formed equations or simultaneous equations. And remember, we are solving them using the matrix method, not any other method, but matrix method. But before we form the matrix from these simultaneous equations, we need to arrange the variables so that they're in line. This is what I mean. In the first equation, we can see that x is beginning, the x variable is beginning, followed by the y variable. Whereas in equation 2, the y variable is beginning, then followed by x variable. So it means that we need to align them. A common variable begin, then followed by the other. Simply, we are going to modify. Let us begin with maybe the y variables. So we have, okay, the x variables. We have the x plus y equals to the 27. Then if we begin with x, we are going to have the negative x, then plus y equals to the 13. This is our equation 1, and this is our modified equation 2. Just modified, but same as the one we have here. Then from here, we are going to form the matrix. From here, so simply we are going to form the matrix. The matrix is coming to be here. X is having a coefficient of 1. Then y is also having a coefficient of 1. Then in equation 2, x is having a coefficient of negative 1. Then y is having a coefficient of 1. So this becomes our matrix that we have got from this. So let us now represent these simultaneous equations using the matrix method or in a matrix form. Simply it means that we are going to have the 1, 1, negative 1, 1 multiplied by the x, y, then it will be equal to the 27 and then 13. So this is the same as these equations we have here. Then from here we are going to apply our method, which is the matrix method of solving it. And since we have two ways, let us begin with part A, or for the adjoint method of solving simultaneous equation. So we are employing the part A, which is the adjoint method. Remember, we have our equation as 1, 1, negative 1, 1, then multiplied by the x, y equals to the 27, 13. So from here we have said that this is the matrix we have. Then we are going to simply get the adjoint of the matrix 1, 1, negative 1, 1. So the adjoint of that is equal to, remember, when we are getting the adjoint of a matrix, what we do, we interchange the entities or the entries in the major diagonal. So we can see we have 1, 1. Let us interchange them, though you may not notice that we have interchanged them because they are both ones. Then for the entries or entities in the main diagonals, we apply a negative sign. Since here it is positive 1, we are going to make it to be negative 1. Then this one, which is negative, when we apply another negative, it becomes a positive, implying that our adjoint of the matrix here is now this. Then after that, we come to the next step. We do multiply this adjoint by this expression. This is what I mean. We are getting the 1, negative 1, 1, 1, which is our adjoint, multiplied by the equations, which are the 1, 1, negative 1, 1, multiplied by the x, y, then it should be equal to. So what I've done on the left, I should do it also on the right hand side, multiplied by the 27, 13. So the next step, we are going to simplify the expressions, whereby we need to multiply. So these are matrices and matrix multiplication. We follow row by column or multiply the row by the column. The row is this, then the column are these ones. So we are going to multiply following the row by the column. This is what I mean. The next step, we are going to have this 1 multiplying by the 1 to give us the 1. That's what I mean. 1 multiplied by 1, like that, plus this negative 1 multiplied by this negative 1. Then we are going to have also 1 multiplied by 1, then plus the negative 1 multiplied by 1. Then for the down one here, still row by column, we have 1 multiplied by 1, then plus the 1 multiplied by negative 1. Then we have the 1 multiplied by 1 plus the 1 multiplied by 1. The whole of it under brackets, but multiplied by the x, y to be equal to, still on the right hand side we multiply. We have 1 multiplied by the 27 plus the negative 1 multiplied by 13. Then we have the 1 multiplied by the 27 plus the 1 multiplied by 13. The whole of it under the brackets. So as we simplify further, 1 multiplied by 1, we are getting 1. Then negative 1 multiplied by 1, we have now 1 plus a 1. Then 1 multiplied by 1 is 1. Then plus negative 1 multiplied by 1, we are getting negative 1. Then 1 multiplied by 1 is 1. Then plus, so plus 1 multiplied by negative 1 is negative 1. Likewise here, 1 multiplied by 1 is 1. Then plus 1 multiplied by 1 is 1. The whole of it multiplied by x, y should be equal to, as we simplify, 1 multiplied by 27 is 27. Then plus the negative 1 multiplied by 13 is negative 13. Then the downer one, we have 1 multiplied by 27 to give us the 27, plus the 1 multiplied by 13 to give us 13. As we simplify further, we are going to have the 2, a 0, then a 0, the 2, into the x, y equals to, we can review, this is a 2, this is 0, this becomes 0, and this becomes 2. Then multiply by this. Then we have 27 minus 13, which gives us the 14. Then 27 plus 13, it gives us the 40. So this is what we have. Then from here we still multiply following the row by column. So we have the 2 multiplied by the x plus the 0 multiplied by y should be equal to the 14. So 2 multiplied by x is the same as having 2x plus the 0, then it should be equal to the 14. So simply have 2x being equal to 14. To get the value of x, we are going to divide through by 2 on both sides. So we are dividing through by 2, divided through by 2. Our x value is coming to be 7. Also, the 0 multiplied by x plus the 2 multiplied by y equals to 40. So in here we have 0 plus the 2y equals to 40. We remain is 2y equaling to 40. Then to get the value of y, we are going to simply divide it through by 2 on both sides. So our value of y is now coming to be 20. Implying that therefore the two numbers that you talked of, the two numbers are 20 and 7. You can even prove it that they said the sum is 27. If I get 20 plus the 7, then I must get the 27, which they talked of as the sum. Then if I get 20, take away the 7, I get 13, which they talked of as the difference. So this implies that these values, the y equaling to the 20 and x equaling to the 7, are very correct. So that has been part A, adjoint method, not inverse, but adjoint method. Let us try to solve it using the inverse matrix method, the very example we have. In here, we are going to simply begin from the matrix we formed, or the equations, we represented them in matrix format. So we had 1, okay, this is part B, and we are using the inverse matrix method. Simply from our simultaneous equations, but in matrix form, we had this, then xy equals to the 27, 13. So in here, we say that the adjoint of the matrix, which is 1, 1, negative 1, 1, is, so we interchange the entries or entities in the major diagonal. We interchange them, then we apply the negatives on the entities or entries in the minor diagonal. So this is our adjoint or adjunct. Then from here, we need to get the determinant of the matrix here. So determinant, deta of our matrix, which is 1, 1, negative 1, 1, equals to, so we multiply the entities or entries in the major diagonal, whereby you have 1 multiplied by 1, then minus, so we take away the product of the entities or entries in the minor diagonal. So take away the 1 multiplied by negative 1. So as we simplify here, we are going to have 1 multiplied by 1 giving us a 1 minus the 1 multiplied by negative 1 is now negative 1. And in here, negative and negative comes a positive, whereby our determinant is coming to be a 2. Then from here, we need to get the inverse of a matrix. So inverse of a matrix equals to the 1 divided by the determinant of the matrix multiplied by the adjoint or adjunct. So it can be adjoint or adjunct. So in here, the inverse of the matrix is going to be 1 divided by our determinant, which is a 2, multiplied by our adjoint, which is 1, negative 1, 1, 1. So as we simplify, this is the same as having the a half, negative a half, then a half. So now simply this becomes our inverse. Then the next step, what we are going to do, we are going to multiply the inverse by these equations. So simply the next step, we are going to have our inverse, which is the a half, negative a half, then a half, multiplying our equations, whereby we have 1, 1, negative 1, 1 into the xy equals to, we do the same, so we have the half, negative a half, then a half, multiplied by the 27, 13. So the next step, we are going to just simplify. Let us now simplify by multiplying the matrices. So in here we have a half multiplied by 1 to give us the half, plus then negative a half multiplied by negative 1 to give us the positive a half. Then we have a half multiplied by 1 to give us the half. Then negative a half multiplied by 1 to give us negative a half. Then a half multiplied by 1 to give us the half. Then minus the half. A half multiplied by 1 to give us a half. Then a half multiplied by 1, we have plus now a half into the xy equals to, on the right hand side still we have a half multiplied by 27 to give us 27 out of 2, then minus the 13 out of 2. Then a half multiplied by 27 to give us the 27 over 2 plus the 13 divided by 2. Let us simplify this further. A half plus a half is simply 1. Then a half take our half is 0. Then a half take our half is 0. Then a half plus a half we have 1. Multiplied by the xy equals to, as we simplify this is the same as having 27. Take away 13, the whole of it divided by 2. Then we have the 27 plus 13, the whole of it divided by 2. So let us simplify further. This is the same as having the 1, 0, then 0, 1 multiplied by the xy equals to 27 take away 13 the same as 14. Then we have 14 divided by 2. 27 plus same as 40 by divided by 2. As we proceed, remember we have 1, 0, 0, 1, the whole of it multiplied by the x, y, giving us the 14 divided by 2 is 7, then 40 divided by 2 is simply 20. As we still multiply the matrices on the left hand side, we are going to have the 1 multiplied by the x plus the 0. We are still following the row by column, multiplying row by column, multiplied by y equals to the 7. So in here we have x plus 0 giving us the 7. X plus nothing is giving us the x being equal to the 7. So this is our one of the numbers they are talking of. As we proceed, we can see that also 0 multiplied by the x plus 1 multiplied by y should be equal to the 20. Then from here I have 0 plus y equals to the 20. Nothing plus y equals to y. Then y is simply equal to the 20, which is our correct value. And they are the same as the one we got earlier on using the adjoint methods. We can see. Let us have example 2 before we go to the tryout questions. Number 2 is the total cost of 2 pens and 3 rulers is shillings 8,000. 5 similar pens cost shillings 3,000 more than the cost of 1 ruler. So in here, as we are having our response, we need to begin by just letting, so we can say that let x and y be the unit cost of a pen and a ruler respectively. So having let, we are going to use our variables, the x and y, representing the cost of the unit cost of a ruler, of a pen and a ruler respectively. So let us now analyze the statements that the total cost of 2 pens and 3 rulers is that. It means that if we buy the two pens, so 2 multiplied by the cost of a pen, which is now x, and they are talking of the total. When we say the total, we are going to sum. Then they are also buying the 3 rulers, but each at y cost should be equal to the total cost, which is now 8,000. This becomes our first equation. Then they are saying 5 similar pens. 5 similar pens. 5 pens multiplied by the unit cost of a pen costs shillings 3,000 more than the cost of 1 ruler. So more than, take away the cost of 1 ruler, which is y, should be equal to the 3,000. We name this as equation 2. Therefore, this becomes our simultaneous equations we have formed. Then we need to go ahead and solve them using the matrix methods. And let us begin by using the adjoint method. So these equations can be written in matrix form as the 2, 3, 5, negative 1 multiplied by the x, y equals to the 8,000, then 3,000. So having written that, it means that our matrix we want is now coming to be the 2, 3, 5, negative 1. Then what is the adjoint of this matrix? Adjoint is, so we change the entities in the major diagonals. We are going to change, this is now negative 1. Then the 2 comes down here. Then the entities in the minor diagonal, we apply the negative. So this becomes our adjoint. Then after that, we are going to multiply the adjoint by the equations or the simultaneous equations, but in matrix form, whereby we are going to have the negative 1, negative 3, negative 5, 2, multiplying the whole of this, so multiplying the 2, 3, 5, negative 1 into the xy equals to, so we do the same, negative 1, negative 3, negative 5, the 2, then multiply by the 8,000, then 3,000. So from here, let us multiply following the row by column, the row by the column. In that order, simply we are going to have the negative 1 multiplied by 2 plus the negative 3 multiplied by 5, then negative 5 multiplied by 2 plus our 2 multiplied by 5. Then for this, we are going to have negative 1 multiplied by 3 plus negative 3 multiplied by negative 1. Then the downer one, we have the negative 5 multiplied by 3 plus 2 multiplied by our negative 1. Under the brackets, multiplied by x, y equals to, on the right hand side should be the same. We have negative 1 multiplied by the 8,000 plus the negative 3 multiplied by the 3,000, then the negative 5 multiplied by the 8,000 plus 2 multiplied by the 3,000. The whole of it brackets. So what is now left is just simplifying. So in here we are going to have the negative 2, then minus the 15, then this is the negative 3 plus 3, this is negative 10 plus 10, then this is negative 15 minus 2 equals to, on the right hand side, we have the negative 8,000, take away the 9,000, then negative 5 multiplied by 8,000, we're getting negative 40,000, then plus 2 multiplied by the 3,000 to give us the 6,000. As we simplify, negative 2 take away 15, we are getting negative 17. Then negative 3 plus 3 gives us a 0. Negative 10 plus 10, we get a 0. Negative 15 take away 2, we are getting negative 17. The whole of it multiplied by x, y. Even here, I'd forgotten it. xy. So equals to negative 8,000 take away the 9,000. We are getting negative 17,000. Then negative 40,000 plus the 6,000. We are getting negative 34,000. So from here, still by multiplying row by column, we are having the negative 17x equaling to the negative 17,000. So in here, to get the value of x, simply we are going to divide this by the negative 17 on both sides. So that we get the value of x. Simply x now comes to be the negative 17,000 divided by negative 17. So x therefore becomes a positive answer, which is positive 1,000. As we proceed with the other one also, same as having the negative 17y being equal to the negative 34,000. To get the value of y, simply we are going to divide it through by negative 17 on both sides. So divide through by negative 17 through by negative 17. So our y is now coming to be the 2,000. Therefore, the unit cost of a pen is 1,000 shillings, and that of a ruler is shillings 2,000. You can go ahead and try using part B, which is the inverse matrix method, and see whether you get the same answer like the one we have got here. And these answers are correct. We have the tryout questions here. We have two numbers just. You try out them and you drop the answers in the comment section. We have number 3 and then number 4. Try them out at your convenient time and you let me know which one has failed you. And please, thanks for watching. Subscribe to the channel Elijah Led 2 for more mathematics videos and lessons. See you again next time. Goodbye.